Good afternoon, friends. Now we should come to the discussion of a very important topic of steering mechanism, and I should like to define what is the second part of the steering mechanism, what is basically called the correct steering angle. First one we should discuss, then we should discuss on the turning radius, second point, and the third point we should discuss on the Ackermann principle, what is basically the steering principle. So we should try to cover these three parts in this part of the lecture, part 2. Now if you go to see what is the basically what is how to calculate the correct steering formulation, now you see that this is the front part of a vehicle and this is the rear part of a vehicle. Now as it is the four-wheeler, so you see this, when it is taking a left hand turn, it has got this is the outer radius, this is the outer tire, this is the inner tire, and the outer tire is making an angle theta and the inner tire is making an angle phi. So this is the condition. Now this is now based on this assumption we should do the calculation. So the perfect steering as you referred is achieved when all the four wheels are rolling perfectly under all condition, that is, there is no condition of slip, there is no point of slip. So if this condition is achieved, then it is called, then it is called as the perfect rolling condition. It is called as the perfect rolling condition. Now while taking a turn, the condition of perfect rolling is satisfied if the axis of the front wheel when produced, if this is the axis, these are the axis of the front wheels, when produced meet the rear wheel axis, should meet the rear wheel axis at one point, If this condition is achieved, then it is called a perfect rolling is satisfied by that steering system of the vehicle. Then this point is known as the instantaneous center of the vehicle. It is seen that the inside the wheel is required to turn a greater angle than the outer wheel. We know that. Now as we have seen that the inside wheel is required to turn to a greater angle than the outside wheel. The larger the steering angle, the smaller is the turning circle. So if we increase the now over here we see that the inside wheel makes an angle of phi and the outside wheel makes an angle of theta. So the inside wheel is making the larger the steering angle, the smaller is the turning radius. So the larger the steering angle it makes, the larger, if you go on increasing the angle of the steering, so the smaller the radius through which a car can rotate. So it is actually the required criteria for every vehicle, so to get smaller turning radius. So for that reason we require to get a larger steering angle. Now there is a limit up to which we can go. So it has been seen that there is a maximum to which we can go. It has been found that for that the steering angle can have a maximum value of 45 degree, So this can have a maximum value of 45 degree. The extreme position on either side are called lock position. At this angle, the extreme position on either side, that is the inner and the outer side, are called the lock position. Now see, they are called the lock position. Now so the extreme. Now the diameter of the smallest circle with the outer front wheel of the car can traverse. Outer front wheel over here, which one is the outer front wheel? The outer front wheel is the this one. So the smallest circle, which is the outer front wheel, the diameter of the smallest circle, which is the outer front wheel of the car, can traverse and obtained when the wheels are at extreme position is known as a turning circle. So the smallest circle the outer wheel can cover, this outer wheel can cover efficiently, and when the wheels are at extreme condition is called as a turning radius of the wheel, is known as a turning circle, and the radius is called a turning radius, which is the important parameter for different vehicles, because there are nowadays very short spaces are available for turning. So this is an important criteria. So the outer radius, the outer circle will covers a maximum will cause a minimum, sorry, the outer radius when cover the minimum circle, when cover the minimum circle, when rotate along the center of and cover a minimum radius, that circle is called the turning circle, and the radius of the circle is called the turning radius. So it is different from various curves, from primitive curves, Hindustan ambassador curves. The turning circle on right hand is taken as 10.83 millimeter, and for the turning circle on right, and while for the left hand is taken as 10.7 millimeter. The turning circle on the right hand, this is the turning diameter basically. For Tata bus LP12010, LP1210E by 52, turning circle diameter is 21.6 meter. And nowadays for modern sophisticated vehicles like Honda MS, the turning radius is found to about 4.7 meters. The turning radius is found to about 4.7 meters. As referred by them, the turning radius is found to about, not the diameter, it's the radius. Turning radius is found to about 4.7 meters. So this is the thing which we get, which we defined. Now we should come for the derivation part of the the perfect rolling the perfect rolling of the wheel, the derivation equation for the perfect rolling of the wheels. Now we could see that cot phi is equals to what? Base by height. So what is the base? What for correct cot phi is equals to y by c. Y by c means what circle? This is the inside, that is the inside circle, because the correction left turn. So this is the outer circle, this is the inside circle. So for the inside circle, the cot phi is equals to y plus c by b. This is the b. So y plus c by b, where phi is basically, this phi is basically the angle of the inside block. Phi is basically the angle of the inside block. Now if we divide this, we get y by b plus c by b is equals to cot theta plus c by b. Now the thing is that what is cot theta? Cot theta is given by y by b. Cot theta is given cot theta is given as cot theta is given by y by b. Exactly, cot theta is given by y by b. Now this cot theta is basically the outside the angle of outside block, because this is the maximum block, this is the locking angle. Cot theta is the maximum locking angle for the outside tire, now or for the outside wheel. Now we get this formulation. If you transfer this, cot phi minus cot theta is equals to c by b. This is for a perfect rolling condition. This condition is achieved for a perfect rolling of the wheels. Cot phi minus cot theta is equal to c by b, where phi is the angle of the inside lock, and theta is the angle of the outside lock. Now if you want to calculate for the inner front wheels, now if you have to calculate the radius of the inner front wheels, how to calculate the radius of the inner RIF, that is the inner front wheel. Inner front wheel is equals to balls. Inner front wheel is this one. This is the inner front wheel. How to calculate the radius of the inner front wheel? So inner front wheel is given by b by sin theta. B by sin theta is basically what? B by sin theta is basically this distance. B by sin theta is this distance, and what? B by sin theta minus a minus c by 2. So so if you take a radius like this, so what happens? So it should be this is what should be A. A is the track, A is the wheel track distance. So there should be A minus c by 2. This is half. This is a half. That is A minus c by 2. This length. A minus c by 2. This length. So RIF, that is the radius of the inside circle, should be equals to b sin theta minus a minus c by 2. For outer front wheel, ROF is given as b by sin theta plus a minus c by 2. Now we have minus this for this is for outer. It should be this one. This should be this one. So it should be plus. So for outer front wheel, it should be b by sin theta plus a by c by 2. Now for inner rear wheels, it is given by r by r is equals to b tan theta. B tan theta minus b tan theta. Tan theta means basically this component. So this component should be how much? This component should be how much? B tan theta minus this is basically tan theta. This is tan theta is equals to y. So this is y. If you see that tan theta is equal to b by y, then y is equal to b by tan theta. So this component is y, this region is y. So if you find that for the inner rear wheel, RIR is given by b tan theta minus a minus c by 2, and for outer rear wheel it is given by b tan theta plus a minus c by 2. Now we go for an Ackermann mechanism. Now this the figure shows the mechanism, this Ackermann mechanism. Now link RA and SB, link RA and SB. So this is RA, this is the link RA. I have given the name. This is the link RA. This is R, this is A, this is S, this is B. Okay. So the link RA and SB, the link RA and SB, the link RA and SB are integral with the stub axles. As I've discussed in my previous lecture, the link RA and SB are integral with the stub axle. These links are connected with each other through track rod. These links are connected with each other through track rod. This is a track rod or tie rod. I have discussed in my first lecture. These links are connected with each other through track rod AB. When the vehicle is in straight ahead position, these links made equal angles alpha. So these links make equal angle alpha when the vehicle is moving straight ahead. Alpha with the center line of the car. With the center line makes equal angles alpha with the center line of the car. So these equal angles alpha are made to the center line of the car. So now the details of the lines indicated is now let L be the length of the track rod. Now we zoom this portion. We zoom this portion. We zoom this portion and transfer it over here. We do zoom this portion and transfer this over here. So to see the bigger version. Now we see that let R be the length of the track rod. This is R. Let R be the length of the track rod. Sorry, let L be the length of this track rod. So this length of this track rod or tie rod is AB. Okay, and R be the length of R, and R be the length of RA and SB. Now neglecting the obliquity of the track rod or tie rod in the turned position, the movement of A and B, the movement of this A is moved when it is taking a turn. When it is taking a turn, suppose in the left front turn, then A will move to A dash and B will come to B dash, and B will come down to B dash. A will move up to A dash, upwards to A dash, and B will come down to B dash. So the obliquity of the truck rod in the turn position is if not considered, we neglect this, then the movement of A and B in the horizontal directions may be taken to be equal, which is x. Then the movement in the horizontal direction, then the movement in these horizontal directions may be taken equal, and let it be x, Now we see that sine alpha plus theta is equals to sine alpha plus theta. Now what is the sine alpha plus theta? This alpha plus theta. So this sine alpha plus theta is equals to y plus x by r. This is r is the length of RA. So sine alpha plus theta is equals to y plus x by r, and sine alpha minus theta over here, this sine alpha minus theta, this angle is equals to y minus x, this portion. Then this angle y minus this y minus x, then this alpha minus theta, that is y minus x is taken as sine alpha minus theta. So sine alpha minus theta is equal to y minus x, because B moves down to B dash. Now if we add these two components, what we basically get, we basically get sine alpha plus theta plus sine alpha minus theta is equals to y plus x by r plus y minus x by r, which is equals to 2y by r, and which is equals to 2 sine alpha. Now how the sine alpha is equals to, when it is in the normal condition, if you see in the normal condition, sine alpha is equals to y by r, y by r. So in case of 2y by r, we put the value of r by y by r as alpha. So we get this form that sine this condition sine alpha plus, if we get this one, sine alpha plus theta, sine alpha plus theta and sine alpha minus theta is equals to 2 sine alpha. This is the Ackermann's mechanism. Now you think that this mechanism gives only 3 points of correct steering. Now 3 points of correct steering when theta is equal to 0. The first one is that when theta is equal to 0. So when theta is equal to 0, that is no turning is taking place. and the other two corresponds to the turning to the right or left at a fixed turning angle. However, for other angles also, it gives a close approximation to the ideal condition. Further, this has the advantage that it employs pivots and not sliding constraints. It employs pivots. It employs the pivots. All the pivot joints are there. It employs the pivots. It employs the pivots and no sliding constraints, due to which reason its maintenance is easier. That is why it is universally employed. However, lately the automobile dealers do not care to follow the Ackermann mechanism very strictly on account of the improvement in the suspension and tires. So that is all about this up to this part. So we should be discuss the remaining part of the gears, about the gears of the different type of rack and pinion gears and all the type of gears in the third part of the steering system. So if you like my lecture, put a thumb mark to it and subscribe to my channel for more videos relating to automobile and mechanical engineering. Thank you. Have a good day.